I welcome all of you who are interested in understanding this particular concept in maths. Okay, let's look at the question. The question says, the diagram below shows a parallelogram ABCD. The coordinates of A, C, and D are 2, 3, 4, -3, and -1, 3 respectively. Okay, so a parallelogram is given there on a Cartesian plane. Let's look at part 1 of the question. Find the gradient of the line joining points A and D. Okay. So part 1 of the question is asking us to find the gradient. Okay. The gradient of the line joining points A and D. The gradient of which line? The line that joins A and D. So A is there and point D is there. So that means we are finding the gradient of this line. Okay. And that means we should know the formula for gradient here in order to calculate the gradient. And the formula for gradient says change in y divided by change in x. Change in y simply means y2 minus y1, and change in x simply means x2 minus x1. Looking at our formula, we will need two sets of coordinates because 1 and 2. And the two coordinates are given there, 2, 3 and -1, -3, because we are interested in the line that joins them. So that is the coordinates that we will be using here, 2, 3 and -1, -3. So those are our two coordinates. And what we have to do, it would be wise if we label it. So x1, y1, x2, y2. Okay, so the labeling have already been done. Now we just have to substitute the values. y2 is -3, the minus from the formula. Okay, our y1 is +3 divided by our x2 is -1, the minus from the formula, and our x1 is 2. Okay, so solving further, -3 will give us -6, -1 -2 will give us -3, and -6 divided by -3 is +2. Okay, so that simply means that the gradient of this line, our line is +2, and that answer makes sense because you can clearly see that our line is pointing towards the positive side. So that means we should have a positive gradient, and our gradient was positive. Okay, so our answer makes sense. Now part 2 of the question, find the equation of line BC. Part 2 of the question, we are interested in line BC. So this is line BC. We have to find its equation. Okay, and you can clearly see that this line is a straight line, and the form of straight line equation is mx plus c. Okay, so that means we should know our gradient and y-intercept. Only two things we need to know in order to write our equation, and those two things are gradient and y-intercept. Okay, but our line BC is parallel to line AD, and something about parallel lines that you need to know is that they have same gradient. They have the same gradient, and the gradient for line AD we have already calculated, which was 2. So that means the gradient of line BC is also 2. And for you to imagine this in the real life situation, it should make sense because gradient is all about slope. And looking at the angle in which this line is elevated, that angle will be the same in which line BC is also elevated. This is what I'm talking about. For example, if the angle here, let's say it is, it looks like 45 degrees. If it was 45 degrees, then this angle here is also 45 degrees. So that means this line is elevated at 45 degrees and this line is also elevated at 45 degrees. So that means they will have the same slope or the same gradient, and that value is 2. So that means we already know our gradient for this line BC. It is same as line AD, which is 2. What we just have to calculate is our C, or the y-intercept, that we don't know. And in order to use C, we need a coordinate. And the coordinate is there because we are interested in line B and C. Even though we don't know the coordinate for B, we know the coordinate for C. It is 4, -3, and we can use this coordinate to calculate our y-intercept. Now I'll use this coordinate to calculate the y-intercept. The coordinate is 4, -3, x and y. So in place of y, we put -3 there. M, the gradient is 2, and in place of x we put 4 there, plus c. So negative 3 equals 2 times 4 will give us 8 plus c. Making c the subject, we will take this 8 on the other side. Opposite operation, it is positive here. When we will take the other side, it will be negative. So our c is negative 11. So there you go. Our gradient is 2, c is negative 11. Now we just have to rewrite the equation, which is y equals mx plus c. But now we just have to substitute the value of gradient and our c, our y-intercept. So y equals our gradient is 2x plus our c is negative 11, but you know plus and minus together we will always choose minus, so our final answer is 2x minus 11. That is our final answer for part 2. Now for part 3, the last one, calculate the length of line segment AD. Now coming back to line AD, but the question is asking us to find the length. So that means we will have to use the distance formula here. We are calculating the distance between A and D, and the distance formula is square root of x2 minus x1 squared plus y2 minus y1 squared, everything under the square root. Looking at our formula, we again need two sets of coordinates here, and since we are calculating the length of A and D, we will take the points of A and D. The coordinate of A is 2, 3, and the coordinate of D is negative 1, negative 3. Again, it would be wise if we label it, then we substitute it in the formula. So x1, y1, x2, y2. Okay, the square root. Our x2, the value of x2 is negative 1. The minus from the formula, our x1 is 2, everything squared, plus our y2 is negative 3. The minus from the formula, and our y1 is 3, everything squared. Okay, so square root of minus 1 minus 2 will give us minus 3 squared, plus minus 3 minus 3, that is minus 6 squared. And negative 3 squared will give us positive 9 plus root of, negative 6 squared will give us 36. Okay, and 9 plus 36, that will give us 9 plus 36 will give us 45. Okay, and root of 45, that can be your answer, or if you want to solve that further, you can press root 45 in a calculator. Will give you 6.708, so that is 6.71, and so our final answer will be 6.71 units. Okay, so this 6.71, that is the distance between A and D. This distance between A and D, the value is 6.71.